Hello, everyone. I'm Joshua Wacks, and today I'm going to be speaking about age estimation, some of the deep learning models, the problems they have, and my specific research that I did into this. Um, so what is age estimation? Well, as a whole, this domain is broken up into three main fields. The first being age invariant face recognition, where the purpose of this is to uniquely identify an individual regardless of age. So if we have two images where an individual is 5 years old and 50 years old, are we able to determine that that's the same individual? The second is age synthesis, where if I give the system an individual age 10, what would they look like at 20 years old? What would they look like at 50 years old? And there have been some Snapchat filters that do this in more of a humorous way, but it is a real field. And finally, there's age estimation, where the purpose of this task is, can we determine the age of an individual from that image alone and nothing else? And this is what I'm going to be focusing on today, the specific part. And traditionally, over the past years, this task was tackled using handcrafted techniques. By that, I mean, we knew exactly what we were doing and what to look for. In other words, create a system that looks for wrinkles or facial hair. However, with the advent of deep learning, this has been highly dominated by the use of convolutional neural networks. Not because we understand them better, because we don't. They just greatly outperform handcrafted techniques. And that's just such a big advantage. Awesome. So we know what age estimation is. Why should we care about it? Well, it has a vast variety of applications. The first being targeted advertisement. If we know how old our user is from their image or from their where they are in the store, whatever, we can show them the exact advertisement that would appeal to them most. It can be used in age-regulated activities to, let's say, prevent underage users from buying cigarettes. And finally, to helping crime prevention for demographic analysis. And we should care about age estimation because it's a hard problem. And we should care about hard problems. Why is this such a hard problem? Well, firstly, aging is such a unique process. I'll get into this in a little bit more detail in a little bit, but compared to facial recognition and other tasks which are almost seen as solved today, age estimation as a whole is still a very open field. Face recognition, in terms of accuracy scores, you don't want anything less than 98, 99%, while the best research teams are still sitting around 70% on their age estimation models. Not only this, there's makeup, and facial features can be obstructed, and differences in lighting, and differences in background, all very important things we need to take into account when making these estimations. And whatever we learn about in this field is carried over to the greater domain of computer vision. So anything that we take and we're like, this is a great way of tackling this, will go towards all the other spheres within this. Great. So as Rahul pointed out really nicely, deep learning has made strides. Computer vision has made strides in the most recent years. However, there are really big problems in this field as it stands, leading to real world problems. In 2017, there was a man arrested in Michigan due to what was called a faulty facial recognition match, where the police will determine that this was the same man that the facial recognition was picking up. And when they had actually looked at him and looked at the picture, it wasn't. And this led me down the road that how can something like that happen? And there's this idea in software, computer science as a whole, that a system is only as good as the data you give it. And no matter how good the model is, if the data's trash, the system's trash. So what I have here is the data sets that many of the prevalent age estimation models learn from today. And as you can see, they are highly biased towards certain ethnicities. And this is true all over the world. Like if you look at the age estimation models trained in Asia, many of them would be highly dominant by the population there. So then they carried research out, and they found that when a model is trained on a highly biased data set, such as Celeb A, this bias will carry over to the results. This led some researchers to create Fairface, which was a new data set created to overcome this exact problem. And as you can see, it's a lot more balanced towards the ethnicities that may come across. However, this led me to a new question, that even if we have a balanced data set, such as Fairface, are there certain individuals, certain genders, which are specifically harder for an age estimation model to predict? It seems clear, right? A man grows facial hair, a woman doesn't. It will be a bit harder. However, I wanted to dive into this deeply and see where it would take me. Yeah. So I'm going to, without going into too much detail, I'm going to tell you how I did this, what model I used, how I trained this model, and what my findings were. Let's take a look. So here's the data set I had used. I had built off of the Fairface data set I had showed you earlier. This time I had counted for, this is a graph of genders, which is almost perfectly balanced. As you can see, the ethnicities are perfectly balanced and the age groups are normally distributed. I did this in hopes that whatever my results were, there'll be no bias that could be pointed towards and say this caused those results in the final conclusion. Awesome. What model did I use? I used the ResNet34 model. This is a convolutional neural network model. What that means is it's really good at vision tasks. And why does it have the name ResNet34? Well, there's 34 layers in the neural network, and it uses residual connections to overcome what is known as the vanishing gradient problem. The vanishing gradient problem is just a problem that affects larger neural networks, where as the model learns and it has so many layers, that the earlier layers that get the immediate feedback take the derivative and pass it down to previous layers. By the time it has run through 34 layers, those differences are so minuscule that there's no changes. How does it overcome this problem? It uses these skip connections. So it takes an input and it will skip some layers to feed in direct input to those layers. It was also used in comparative research, which was quite nice. Yeah, here's how I went about my research. A little bit normal machine learning activities, where I had a Fairface data set, the one I had showed you to train my model, a separate data set, UTK face, which I held out. That I was going to test on separately. Did some pre-processing, did some validation, hyperparameter stuff. All of this to create a model which would at some point be competitive with what I saw in the research at the time. Before I get to some of my final results, let's take a look at some of the predictions it made. Here were some of the correct predictions it made. And if you're wondering, I did upload images of myself and it worked. And then it guessed my age correctly. So those were some of the correct predictions. Here are some of the incorrect predictions that I made. As you can see, it's such a difficult task because if it's off by one age group, it's marked as incorrect. So ask yourself maybe, how old would you think these people are? And it's quite a difficult task. When this is taken into account, when it's off by one age group, it does significantly increase the accuracy. But of course, we want it to be correct. Cool. So here were the exact results that I had. If you can see on the test slit of the Fairface, which was the data set I trained my model on, it achieved around a 56% accuracy. And the UTK face data set, which was the one I held out, that was around a 53% accuracy. And this may seem low, but it was only a few percentages below what was exactly in the research at the time. And it may seem like 50%, isn't that just a coin flip? It's way above random. So it was making good predictions. However, like I said, it becomes a very difficult task. Let's take a look at the findings. Did I answer some of the questions that I had posed in the beginning? Well, I had found when you had taken into account the bias from the data sets and removed that, there were no significant differences in accuracy between genders. Genders performed very similarly. Same with ethnicities. However, there were some major differences between age groups. Being the younger age groups performed significantly and consistently better than the older age groups. And when one steps back and thinks about this, it becomes obvious that when someone's young, they haven't had many life choices that can affect how they age. If they live in a different environment, the environment hasn't affected how they age yet. So someone who's 10 generally looks similar to someone who's 10 anywhere in the world. However, as people age and they make life choices, it becomes more and more difficult. So that's why you can see as it drops off here, between like anything above 40, you even below 40% accuracy. And that's because someone who looks after themselves at 60 years old can look 40 years old. And that's why this is such a particularly difficult task. And I hope that some of the research that I had done maybe adjust the data sets that the models learn from to overcome this problem in the future.